Hi, welcome back to class. Today, we'll be walking through a worked example that will further help us understand capacitors in series and in parallel. In case you missed our previous lesson, please do not hesitate to check the description below. Welcome back. I will advise you pause this video and take a look at this question and try your hands on it. Two capacitors have capacitance 4 microfarad and 2 microfarad respectively. They are joined in series with a battery of 100 volts. The connections are broken and the terminals of the capacitors are then joined. Find the final charge on each capacitor. Now the first thing I want us to do is to do a diagrammatic view of these capacitors. In the first instance, both of them are joined in series and connected across an 100 volts battery source. That is, they are what? They are charged. As charges begin to build on these, and because they are connected in series, the charge Q across my 4 microfarad, that's Q1, is the same thing as the charge Q2 across the 2 microfarad. Then in the next instance, they are what? The question says they are broken. And when they are broken, they are connected in parallel because the question says both ends are joined together. At this stage, there's a redistribution of these charges. So we have to calculate the redistributed charge. Let's call this Q2, Q3, and let's call this Q4. Now let's get into work. Now at the first stage, when they are connected in series, my total capacitor is CT, which is equals to 1 all over 4, or 1 over CT is equals to 1 over 4 plus 1 over 2. So that 1 over CT will be the same thing as, here is 4, this will be 1 plus 2. 1 over CT will be the same thing as 3 over 4. So that CT will be the same thing as 4 over 3 microfarad. Now, if CT is equal to 4 over 3 microfarad, then we can calculate for Q. Q is the same thing as CV. So that Q now will be the same thing as 4 over 3 times 10 to the power minus 6 times 100, which is the same thing as 400 over 3 microcoulombs. Charges are measured in coulombs. Coulombs can simply represent it as a C. Now, if this is Q, we've been told that Q1 is equals to Q2. So that the total capacitance built here, QT, is the same thing as 2Q1, which is equals to 2 times 400 over 3 microcoulombs. That's equals to 800 over 3 microcoulombs. Each of them have the two combinations, as 800 microcoulombs. Now we can now check them when they are in parallel. They are in parallel before redistribution. The total charge across this combination we've been given is 800 microcoulombs. So we've not been told of the capacitance and the voltage. But because they are in parallel, the voltage across both combinations will be the voltage across each combination, and the voltages will be equal. Now let's take the capacitance. My capacitance CT, because they are in parallel, will be the same thing as 4 microfarad plus 2 microfarad, which is equal to 6 microfarad. Now, so that my Q now we know is equal to CV, meaning my V, this implies that my V is equal to Q over C. So that my V in this instance will be the same thing as 800 over 3. That's 800 over 3, not just 800. 800 over 3 microfarad. 8 microcoulomb. 800 over 3 microcoulomb, that's times 10 raised to the power minus 6 times 1 over 6 times 10 raised to the power minus 6. So that 10 raised to the power minus 6 cancels 10 raised to the power minus 6. 2 here is 3. 2 in 800 is 400. So that my total voltage V will be the same thing as 400 over 9 volts. 400 over 9 volts. Now with this, you can now begin to look at the charge across each of the capacitors. My charge Q, again, is equal to CV. So my Q3 will be the same thing as 4 times 10 raised to the power minus 6 times 400 over 9. So that Q3 obviously will be equal to 1,600. 4 times 400, that's 1600, times 10 raised to the power minus 6 over 9, which is 178 microcoulombs from my calculator. Then for Q4, I can just calculate Q4 here. Q4 will now be the same thing as 2, that will be the same thing as 2 times 10 raised to the power minus 6 times 400 over 9. That will be the same thing as 800 over 9 microcoulombs. Now you can just solve that with a calculator. Now, with this, I hope you understand the unique difference between capacitors in series and in parallel. Thank you for staying with us and see you in our next class.